3.3, it says which graph, number 20, says which graph matches this. So let's just find out some things about this. The line of symmetry is minus b over 2a, x equal, which is going to be the opposite of 2 over 2 times 1, which is 2. And so we get negative 1. So the graph has to have an axis of symmetry at negative 1. What's the y-intercept? Well, this one, if I put in 0, 0, the y-intercept is 2. Does it open up or down? No, it's a positive 1, so it has to go open up. And it's a 1 in front of this, so over 1, up 1. So the vertex must be here at negative 1, 1. And so now I can look at the different graphs that they offered me to select from. And if I look at the different ones in this section on that problem, get to that page, looks like D is the graph that will look like that. Okay, 32 says find the standard form for this. So we have to get it to be, standard form means y or f of x equals a times x minus something squared plus something. So I got to complete the square. First thing is we want a 1 in front of the x squared to do that. So we're going to write 2 thirds, 2 thirds, take the 2 thirds out of the first 2, so 2 thirds times x squared is 2 thirds x squared, 2 thirds times 2x would be 4 thirds x, leave some room and leave the minus 1 sitting out there. Now what we learned in circles, we use x plus half of 2, which is 1, squared. And that will be times 2 thirds. But this x plus 1 squared, if I go up and do x plus 1 times x plus 1, I get x squared plus x plus 2x plus 1. That is, we have the x squared plus 2x, but this has a 1 extra, so I have to put in 1 and take it out. So by doing that, I haven't changed this problem up here, but these first 3 are this. So I have 2 thirds times this, or 2 thirds times those 3, but now I have this minus 1, so I got to take 2 thirds times the minus 1, which is minus 2 thirds. And then minus 1 on the outside, so it becomes 2 thirds x plus 1 squared minus 1 2 thirds. So now after I've done that, it says what's going on. So this is a regular standard parabola that's plus 1 moves it left 1. Then on the outside, this 2 thirds would happen first, so it takes it 2 thirds as far from the x-axis, so it's a compression towards the x-axis of 2 thirds, and then it's down 1 2 thirds. Okay. 36. It asks things about this parabola. It has a whole bunch of things it asks about. First of all, does this open up or down? Well, the negative in front of the x squared makes it open down. What's the vertex? An axis of symmetry. The axis of symmetry is x equal opposite of b over 2a, which is 2. So the vertex is 2, and if I put 2 in there, 2 squared is 4 times the negative is negative 4 plus 8, which is 4. There's the vertex. X-intercepts. Well, this conveniently factors. I can pull out an x and I make y be zeros and take out an x and I get x times negative x plus 4. So the x-intercepts is going to be 0. If I set x equal to 0, I get one of them. X-intercept of 0, when y is 0, and an x-intercept of, see, I put 4 in here, negative 4 plus 4, so 4 will make it be 0. Y-intercept, if I put 0 in for the x's, I get 0, so which that's a y-intercept and an x-intercept, and that's an x-intercept. So this is a parabola, vertex at 2, 4. It's upside down, so if I move over 1, it goes down 1, over 1, down 1, because it's a 1, so it's not stretched vertically. And over 2 would be down 4, down 4. So it has an x-intercept at 0, 0 and at 4, 0. The domain, any real number, can be put into this. The range, what I get out, will be from negative infinity on up to 4, including the 4. It's increasing, it's growing, it's going uphill as I go across left to right, from negative infinity up till x is 2. So it's increasing from negative infinity to 2. Not at 2, 2 is changing. And then from 2 on, not including the 2, it's going back down. That's what they wanted you to do for 36. They wanted you to do the same kind of stuff for 38. So, first of all, this one is, since it's a plus 3 in front of the x squared, it's right side up. And it says, what's the vertex and the axis of symmetry? Well, the axis of symmetry would be x equal the opposite of b, that would be plus 8 over and negative opposite of b over 2a. 2 times 3 is 6, so I get 8, 6 or 4 thirds. So the vertex is at 4 thirds, and then I'd have to put 4 thirds in there. 4 thirds times 4 thirds is 16 ninths times 3 minus 8 times 4 thirds plus 2. So this is 48 ninths minus 4 times 8, 32 thirds. 3 to 46, 8 times 4 is 32. What did I do? 4 thirds minus the opposite of b over 2 times a. Okay, that's right. Plus 2. So let's see, 48 ninths in 45, that'd be 5 and 3 ninths minus 10 and 2 thirds. 3 ninths is 1 third. So notice this is twice as much as this. I thought it wasn't, but it is. Plus 2. So 5 and a third minus 10 and 2 thirds is minus 5 and 1 third plus 2 is minus 3 and 1 third. Vertex, axis of symmetry, we're supposed to do intercepts. The X-Intercepts, I'd set this equal to 0. Does that factor? 6. Nope, so I'm going to have to do, I'll use the quadratic formula. The opposite of b plus or minus the square root of b squared, so that'd be 64, minus times 2, positive times positive, that's going to be minus. 2 times 4 is 8, times 3 is 24. 64 minus 24 over 2a, which is 6. So 64 minus 24 is 40. So I got 8 plus or minus square root of 40 over 6. I can reduce that, but I'm not going to worry about it. So my x-intercepts are 8 plus the square root of 40 over 6, comma 0, and 8 minus the square root of 40, all over 6, comma 0. My y-intercept, if I put 0 in for the x's, I get 2. So 0 for the x's, I get 2 for the y. And then, what else did they want? The domain. This parabola will go on forever and ever. Sideways, I can put any x in, so the domain is all reals. The range, since the lowest place, the vertex, is at -3 1/3, and then it goes up from there, the range would go from -3 1/3 to infinity. And it would be increasing from the axis of symmetry this way, which is from increasing on the interval 4/3 to infinity, and decreasing from -infinity till we get to 4/3. And it says do a graph. I think you could probably graph it with vertex there and figure out what these decimal values are for the intercepts and be able to draw this. Okay, 64. We're supposed to graph this. Let's just do it. I can just, if you don't have a calculator, let's show you how you do that. So if I put in 0, I get -8. 5, 6, 7, 8. If I put in 1, I get 1 minus 2. 1 minus 2 is -1. Minus 8 is -9. If I put in 2, I get 4. Minus 4 minus 8 is -8. And if I put in -1, I get 1 plus 2 minus 8, which is -5. 1, 2, 3, 4, 5, and there. And I can kind of see that I've got a pattern going here. So there's my graph. I just put points in. I can also say what's the axis of symmetry. That's going to be minus the opposite of b, plus 2 over 2a, which is 2. So the axis of symmetry is at 1. That's why I hit the low spot there. So the domain is all reals again. I can put any number in for x. The range is going to be from -9 to infinity. Including the -9, sorry about that. It increases from 1 for x is greater than 1. So from 1 to infinity, this parabola is going up because it's got a positive, it opens up. and it's decreasing from negative infinity, x negative infinity, up till x gets to 1. Now, we're supposed to do kind of the same stuff for this one. Well, this one is in the form where we know the transformations. It's a parabola, mother parent function, moved -1. So that's the axis of symmetry. Then it's flipped upside down and stretched by 3. So 1 over, it's going to go down 3. And 1 over, down 3. But the whole thing is moved up 4. So the vertex is going to be at -1, 4. And if I move over 1, it's going to go down 3. 1, 2, 3. And 1 over 1 the other way, down 3. And this is what it looks like. And so it says graph it. What's the domain? And that would be any real number. Range. It goes from negative infinity up till positive 4, including the 4. It's increasing all the way until x gets to -1. From negative infinity to -1, this curve is increasing, and it's decreasing from -1 on the x till x goes to infinity. This thing is constantly going down. I think that's what they wanted you to do on 68. 72. It says we got an equation and it has a vertex at 1, 4. Well, if we instead of writing this form, let's write the other form. That means it's f of x equals some number times, if the vertex is at 1, it's got to be x minus 1 squared. And it must be moved up 4. We just don't know what the vertical compression or stretch is. So if we put in -1, we should get -8. So I'm going to write -8 equals a times -1 minus 1 is -2 squared plus 4. Subtract 4, and -2 squared is 4, so divide by 4, and a equals -3. So we know that the equation in this form is 3 times x minus 1 squared plus 4. To change it to this form, to find the a, b, and c that they want, I would square this. So I'm going to get 3 times x minus 1 times x minus 1 is x squared minus 2x plus 1 plus 4. So I got 3x squared minus 6x plus 3 plus 4 is plus 7. So there's the a, b, and c. Okay, on 76 they said graph these two. F is a upside down parabola, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Not move sideways, upside down, a 1 in front of it, so it's just 1 over 1 down, 1 over 1 down. 2 over down 4, so from 9 to 4 would be it to 5. And 3 over would be down 9, so it would be clear down here on the axis. Let's draw g of x, which is 2x plus 1, has a y-intercept of plus 1 with a slope of up 2 for 1, 2 for 1, so that one would go right there. And then it says find when they're equal. So let's set them equal. Negative x squared plus 9 equals 2x plus 1. This is going to be a quadratic, so I'm going to move these two to the other side by adding x squared to both sides and subtracting 9 from both sides. So I'm going to get 0 equals x squared, adding x squared to both sides, plus 2x, subtract 9 from both sides, I get minus 8. And if I want to know for what x's are they equal, I'm going to solve this, and I can put it in the quadratic equation, but I can also, I think this factors to x and plus 4 and minus 2. So when then I set these equal to 0, x plus 4 equals 0 means x equals negative 4. X minus 2 equals 0 says x must be 2. So when x is 2, the graphs intersect. Now what's the intersection point? Well, now I need to put 2 back into both of these. Either one of these, it should give me the same answer, and it looks like it's about 5. 2 times 2 is 4 plus 1, 5, yes. 2 squared is 4. Times the minus 1 would be minus 4 plus 9 is 5. So 2, 5 is an intersection point. And at negative 4 something, they intersect. So if I put negative 4 in here, 2 times negative 4 is negative 8, plus 1 is negative 7. And you'd get negative 7 if you put negative 4 into the other one also. Those are the intersection point. Then it says shade the region between where f of x is greater than g of x. The height of the f function, the parabola, is greater than the height of the g function. That's from here to here, f is above g. Over here, f is below g, and over here f is below g, so it's just this part they wanted us to shade. Now it's 76. 80. If minus 5 and plus 3 are the x-intercepts, the parabola must have factors of x plus 5 and x minus 3. Because if you set that equal to 0, x would have to be minus 5 and x would have to be 3. Now it could be stretched or something, and they said make it stretched by 1. So that's the first one they wanted. Now if you multiply that out, you would get x squared minus 3x plus 5x is plus 2x. 5 times minus 3 is negative 15. So that's with a equal to 1. See how it's 1? And if it was 2, it would be just, if it's 1 times this, it would be 2 times this when it's 2, which means it would be 2x squared plus 4x minus 30. And if it was minus 2, it would be minus 2x squared minus 4x plus 30. And if it was 5, it would be 5x squared plus 10x minus 75. So what does this do to the intercepts? Well, the x-intercepts are staying the same. They told us to keep them the same. But the y-intercept is, the bigger the number, the further it gets from the axis. A 2 moves it twice as far up. A minus 2 twice as far, but on the other side down. So this one was at minus 15. This is minus 30, so it went twice as far down. This one's, instead of minus 15, it's twice as far up on the positive side, and this is 5 times as far on the negative side of the x-axis. So it's just moving the y-intercept that much. What happens to the axis of symmetry? Well, the axis of symmetry is always halfway between. Negative 2 divided by 2, it's negative 1. Negative 4 divided by 2 times 2 is negative 1. Positive 4 divided by negative 4 is negative 1. Negative 10 divided by 2 times 5 is 10, is negative 1. The axis of symmetry is always x equal negative 1. Vertex is at -1, and it's going to vary a lot because you put -1 into this, you're going to get an answer. Let's see what it is. -1 squared is 1, -2 is -2 and -15 is -17, -16. Now if you do it times 2, it'll be twice as much, so it'll be at -30. If you do -32, if you do -2, it'll be at +32. If you do 5, it'll be 5 times 16, which is 80, negative 80. So it's just going to move it that many times further away because it does stretching. And the midpoint between -5 and 3 is -1, which is the axis of symmetry. That's what they wanted you to notice about that. And it stayed halfway between the two x-intercepts. That's what they wanted you to understand about 80.